or two for people to join, if you bear with us for a moment. Okay, well, we'll get started now. Good afternoon, everyone. Thanks you for joining our webinar with Hager on AFDD. My name's Jamie. I'm the marketing manager here at Rexel. Our guest today is Paul Chafers, technical training manager at Hager. Please note that this is a recorded webinar and will be available to watch on demand on our Rexel website. This webinar is CPD accredited and certificates will be sent directly from CPD, which can take up to 4 or 5 weeks. If you have any questions throughout the webinar, please feel free to pop them in the Q&A box and we'll go through them and answer them at the very end. Now passing over to Paul from Hager.
Thanks, Jamie. Yeah, just a slight slip of the tongue there, Jamie. This one is on consumer unit design considerations. So we will brush on AFDDs, but we've previously covered AFDDs, and I think you can find that on the Rexel YouTube channel. So please check out the previous webinars there. But this one's all about consumer units and what we should be thinking about when we consider the requirements of the regulations, especially more recent regulations that come up to date. So this should cover all of that. I was due to be joined by my colleague Paul Collins. He's unable to join us this morning, but both myself and Paul have worked on a number of committees over the years, and we sit on BEMA committees for wire and regs and electric vehicle charging, etc. So hope you'll find this useful, and we should be able to deal with any questions that come along throughout the morning. So this is the sort of content of the webinar. We're going to look at the construction of consumer units, why we may choose a different assembly setup for a different client or a different application, with regards to unwanted tripping, the different types of RCDs we need. We're also going to be looking at surge protection. Again, we have covered RCDs and surge protection in detail on previous webinars, but this is a sort of an overview of the complete assembly. We can also look at assembly requirements, something new that came in with the Amendment 2, with considerations when we have generators connected to a consumer unit, so maybe a solar PV inverter, something like that. We need to consider the rating of the consumer unit. As I said, we're going to look at AFDDs, EV charging supplies, and rated diversity factors. So just to start with, let's dive into the unwanted tripping. So this can be found in Regulation 53132. RCDs shall be selected and erected such to limit the risk of unwanted tripping, okay? And it gives us the following. Now, indent 1 is subdivision of circuits with individual associated RCDs, okay? Now, subdivision and splitting circuits up is a requirement of Section 314, division of installation anyway, because we need to minimize any danger. So we need to subdivide circuits, and here is a list of things that we need to do. Okay, so we need to be able to facilitate safe isolation and avoid inconvenience. But with regards to unwanted operation of RCDs, we have this indent 4, which talks about reducing the possibility of unwanted tripping of RCDs. Okay, and this is due to excessive protector conductor currents, not due to a fault. Okay, so more or less every item of equipment leaks some sort of leakage current out of it. Electronic devices, computers, and as these things build up in an installation, the more protective current we see flowing back through a device. Okay, so this is why when we look at this assessment of general requirements here, and then we move into 531, we're starting to pick out these individual points. So we've now had this text introduced in Amendment 2, where it says the use of RCBOs for individual final circuits in residential premises. Okay, so this doesn't mean that we can't use a shared RCCB anymore, but it's just telling us this is another way of minimizing your unwanted operation. And then there's indent 3, which talks about making sure that your RCD, any downstream currents to the RCD, is not more than 30% of the rated residual operating current. Okay, so if you was to look at a 30 milliamp device, that would be 9 milliamps. So if you had a RCCB feeding a bank of circuit breakers, you would need to sort of ensure that you wasn't seeing more than 9 milliamps worth of leakage across those devices before you start to breach this this consideration here. Okay, so it's when you go back to the start of that regulation, these are all things that need to be considered to minimize unwanted operation. Okay, so what I'm going to do is I'm going to sort of look at some boards that you'll be familiar with, some consumer units, and we're going to start with the split load consumer unit. So probably, if memory serves me right, when we went to the 17th edition of the wiring regulations, we went from previously in the 16th edition, where we would look to provide RCD protection for a socket outlet that could be used outside, or it might be for you know, to meet some manufacturer's instructions. It might be a shower circuit requires protection, that kind of thing in the 16th edition. When we moved to the 17th edition in around about 2008, I think that was, all of a sudden there was a lot more requirements introduced where additional protection by RCD was required. So it was cables in walls. We've got cables in bathrooms. We've got lots of requirements for using additional protection, and I'm going to talk about some other ones further on when we look at generators. But essentially, this meant that we had to change the way that we produced consumer units to be able to meet this. So this sort of dual RCD unit, and we call them, everybody in the industry calls them RCDs, but the devices you commonly see in a consumer unit are known as RCCBs. Okay, so if I refer to RCD, I'm referring to RCCB. Okay, so we kind of felt, and the industry kind of felt, that this as a minimum would meet the requirements of sort of meeting that division of installation. If you had an unwanted operation of one RCD, you wouldn't lose total power. You may just lose approximately about half of the power in the installation. So installers would kind of try to think about what circuits were on each RCCB, and you might put the upstairs lights on a different RCCB to the upstairs socket. So if the lights goes out, you might still have a table lamp or something like that that could be used to find your way back to reset the device. So that was kind of the start of this arrangement of board. We always had split load boards, but with the dual RCCBs, it came around about the 17th edition. And then to provide a more flexible unit, the high integrity configurable boards sort of came to the market. And what this allows you to do is use the RCCBs to kind of split the loads, but then have a number of ways that are fed straight off of the main switch, depending on how you configure it and how many ways you choose to use. You could use RCBOs on those ways, AFDDs, or circuit breakers, whichever you thought was the the correct application. And in this example here, we've got a garage that's being fed off of a circuit breaker, because the garage has its own unit with a RCCB in there, and this will provide total selectivity if that was desired. So it gives you an example of how a high integrity unit could be used. And then we talked about garages. This kind of setup is typically used in the garage, and that's why installers tend to refer to them as garage boards, but we would call this an RCCB incomer board, and you can choose how many ways you want, and there's no real need to further subdivide at this stage. You've done it throughout the installation, and we get to a garage. Of course, you could be in a really big garage and it might be desirable to subdivide, but in this instance and in many applications throughout the UK, this would be absolutely suitable, where you've got a couple of sockets and you know, a bit of lighting, maybe a freezer in there, that kind of thing. You're not going to build that much unwanted sort of leakage current that would affect the RCCB from an unwanted operation point of view. Here's an example here with the RCBOs on. So this is where we've got a switch disconnector. So there's no RCD protection built into the actual unit. You're providing that with what devices you install. In this example, it's RCBOs, and this meets that indent that talks about using RCBOs, that they are particularly sort of useful for combating against unwanted operation, nuisance tripping, that kind of thing. We're seeing a lot more of these types of consumer units being selected now. So we've kind of covered the unwanted operation of the devices. Now we're going to look at the RCD types. These are the types, and in years gone by, the type AC was the type of RCD that we commonly saw in consumer units carrying this symbol here. Okay, now with Amendment 2, that kind of got shelved a little bit. I mean, we've been producing type A devices for a long time in our units now, probably over 5 years, but type AC devices, they're not really suitable where you've got a presence of DC current. Okay, so the DC current can pass back through this device and it can magnetize the core of this device and prevent it from working under a fault condition. It's widely sort of known now. We call it blinding, some people call it masking, but you need to be careful, and some installations will actually specify a particular type of RCD to be used. But because of Amendment 2, we don't really see type AC devices as general purpose anymore. We're seeing the type A as being the more general purpose device, because the type A device can work in the presence of up to about 6 milliamps of DC flowing through it. Okay, a type F device can deal with up to about 10 milliamps, and a type B device, that's the best device out of there. That will actually, if there's too much presence of DC, it will actually disconnect. Okay, so that's the kind of hierarchy of devices, the AC being the worst and the B being the best. Okay, so a type A can do everything that an AC can do, plus it's got those extra characteristics. A type F can do everything that the A and the AC can do, and a type B can do everything that the F, A and AC can do. Okay, so very important that you sort of start to look at these little symbols, and they are quite hard to see at times. You need to make sure you've got the correct RCD for the application you're using it for. So there is guidance out there. So Beamer have got lots of guidance documents. They've got RCD selection documents. They're free of charge. Please visit the site and download yourself a copy. And what this image is doing here is actually showing you that there is a little bit of thought process of how we connect these devices. So if you've got two RCDs in series, if you've chosen a particular device downstream because it needs to be able to deal with the characteristics of DC current, if you've got one in series upstream of it, it still needs to be able to deal with that DC current. Otherwise, as the DC passes through it, it will become magnetized. Okay, so if we have a look at the type A device here, it's only feeding type A devices. Okay, so it can deal with everything. Now, this one is a time delayed device because that's dealing with the selectivity side of the design. And it's getting a bit more complicated now because we've got selectivity where we talk about a 3:1 ratio. We might have a 30 milliamp here and 100 milliamp here. So we've met that 3:1 requirement. It's also got to be time delayed. So we've got our S-type device here. So you're starting to think about your selectivity and your coordination of types. And you can see this type B here, it couldn't pass through that type A because this type A couldn't handle the reason why we've chose this type B device is to deal with DC presence, so electric vehicle charging, something like that. So the installer would have to think about how maybe if that was 2 consumer units there, how the towers would be split with some Henley blocks or whatever, and feeding the unit with the type B device in it. So I hope that's clear. But as I say, there's plenty of guidance on there. And this topic is covered on the Hager Online Academy. So please check out their CPD training on consumer units, AFDDs, SPDs, all that kind of stuff is on our site. So next up for consideration is surge. Okay, now these were the 3 indents we had after the DPC. When Amendment 2 come, the process got simplified, the risk assessments went away, and we had a very straightforward regulation. Okay, if you could have the consequence of overvoltage could result in one of those 3, you're required to put surge in. It's a shall regulation, which means you have to do it. Now, it also goes on to say for all other cases, you shall provide it, unless the owner declares it's not required and they're able to accept the consequential losses and the damage is being tolerable. Okay, now what we're finding is a lot of contractors, they're not having that conversation with a client, they're just opting to put the SPD in. Quite often they might not even get to speak to the client if they're working for a builder or whatever. Most of the time they're considering it to save the comeback, any backlash with this, or documenting that decision, they just install that. Now, there was some changes to the regulation when we had the corrigendum earlier in the year. Okay, this indent was removed. So we're now left with 2. If the installation falls into one of those 2, you do need surge. And for all other cases, you should put it in unless there's some sort of process and the client understands the risks. We've also got this regulation to consider. Now, this is not a shall regulation, but it is a shall be considered, which is some clever wording. It basically is telling you need to consider overvoltage protection where you've got switching over voltages. And quite often, I forget what the percentage is, but there's more damage caused by switching loads than actual atmospheric problems. Whilst atmospheric issues are very, if you're unlucky to be wrapped up in that, they can provide a lot of damage. Lots and lots of installations are subject to switching loads, even domestic loads. There's LED lights being switched on, compressors in fridges, whatever, turning on and off. Those little surges and spikes can degrade components in electronic equipment. Okay, so this is why it's important to consider surge. Even if you don't fall into a lightning threat, you've got it there from a switching over voltage sort of application. So I'm just going to take a quick swig of this. Next up on the list of considerations is this requirement that come along in Amendment 2, and it requires the assembly to be selected, so you meet this little formula here. So the INA is the rated current of the assembly. Now, most using consumer units as an example, as that's what the topic is about today, our consumer units are typically INA rating of 100 amps. Okay, so we've got to have an INA rating which is equal to the rated current or setting of the incoming overcurrent protective device, plus any generators that are connected. Okay, so if you had a solar PV inverter that was connected and it was capable of delivering 16 amps, your INA rating of the consumer units would need to be 100 amps if it was a 100 amp cut out fuse, plus the generator 16 amps. We would need an INA rating of 16 amps. Okay, so it's a little image here to try and understand what we're talking about. We've got the 100 amp supply plus a 16 amp supply. What do we do about it? Well, at Hager, we've got a level 4 testing lab, and we've carried out tests to ensure that we can give you a INA rating of 116 amps for our consumer units. So it's only applicable to the testing of a Hager consumer unit where we install it in this configuration. Okay, so none of this can be overloaded. It's all rated for 100 amps and the solar comes in on the end. So if you install it on the end in a Hager unit, we can give you a conditional rating of INA of 116 amps, okay, which meets the wiring regulations. Just take note of this blank here, okay? That is in there from some of my other training material, and I'm going to be talking about at the end of this presentation rated diversity factors. Okay, so we've got this solar here. If it is a nice sunny day, it's going to be producing all day long through that device. Just remember the position of it on the end and with a blank there next to it, and when we get to the section on rated diversity factors, I'll tell you more. So yeah, we've got a technical solution for anybody doing solar PV that's concerned with the INA rating. Now, looking at renewables as well, the topic of current flow direction is come to light in recent times. Beamer have done a document on this as well. And I first started looking at it in Amendment 2 when this regulation 826122 arrived, which is within that new section, Part 8, for prosumers electrical installations. Okay, so a prosumer is somebody that produces electricity as well as consumes it. Now, within that regulation there, it's asking us to take account of possible directions of current flow. And we're used to the term polarity, but current flow, traditionally, we feed loads in one direction. When we talk about renewables, we've got current flowing back into the switchgear. So if you was to look at this, one of our traditional existing RCBOs, you'll notice it's marked here out. We've got it here in the diagram that is in the box of every device. It's marked out. Now, if you was to put solar PV into those terminals, you would be putting an in to an out position, and that would be an installer error, unfortunately, because the device is marked in and out because it can only cope with current flowing in one direction. And the problem is, if you put power in the opposite direction, you can damage the RCD element of the device, and the device will sit there. It will still work on overcurrent, but it may not work if there's a residual current problem, and that could be a problem if you're using the device for additional protection, you know, if the cable's in the wall, etc. Okay, so we now call these devices unidirection. So this is unidirectional. It can only take power in one direction. Okay, and if you look at this device, I'm just going to point out that most single mod RCBOs are not switching the neutral. Okay, is that important? Yes, it is, for some applications. So when we look at the wiring regulations, many installers, they will go to, for solar PV, they go to section 712 and they look up the requirements. But whenever you use a part 7, you always need to use that in conjunction with the general requirements of the regulation. So within chapter 55, which is in the general requirements, we have other equipment. And regulation 551.7 provides additional requirements where you have generators operating in parallel. Okay, so we've been talking about solar PV operating in parallel, but it could be any type of generator. Okay, now where an RCD is used and it's provide an additional protection, so we've got a cable in the wall, for example, and we're feeding say a PV inverter, the requirements of this regulation is that the RCD shall disconnect all live conductors, including the neutral conductor. So be aware, do we really need RCD protection in the first place for PV? You know, you might have surface mounted cables, you probably don't need it, but you may need it if it's a TT installation for fault protection. But where you're providing additional protection, it has to be able to switch the neutral, and a lot of RCBOs don't. Again, Hager have a technical solution where we've got a brand new RCBO, which is going to be coming to the market very shortly, within the next week or so. And this device here is compact, it's single modular. You can see it's not marked in or out. That's because it's bi-directional. So it meets the current flow in either direction, and you'll see that it's 2-pole switch neutral. Okay, so it's not an issue. We've always had these devices in double mod devices. We've now got them in single modular devices. So not a problem. The solution is there. And like I say, if you need any more material, please check out the Beamer document on this topic. So we're now moving on through and we've got to arc fault detection devices. Now, we have done a webinar on this in full, and that should be on the Rexel YouTube channel, so please check it out. But I'll just give you a quick summary of it. We now have a mandatory requirement to include AFDDs for single phase AC final circuits supplying socket outlets with a rated current not exceeding 32 amps. And that's in 4 locations. I'll just bring those up. Now, to give you a little bit of background behind this, during the discussions at committee level, we kept coming back to socket outlets because there's no control over what's being fed from them. Could be extension leads that are getting damaged, cables that are getting trapped. So that's kind of why socket outlets were focused on. And then we started looking at where they were required everywhere, possibly not, but what buildings would justify them. So we started looking at this was in light after Grenfell Tower. We started looking at difficulty for evacuation in high-rise buildings, and we could see that additional fire protection by AFDD would be you know, particularly suitable in those higher risky types of environments. Again, houses multiple occupancy. We've seen a lot of HMOs where they've been extended and not been done that well. They're not really designed to carry the load, so 3 or 4 families living in them. Those families tend to or may want to not use the shared kitchens, and they put appliances in their rooms. They get a lot more load within the a lot more extension leads being used. Purpose-built student accommodation was chosen because students will you know, purchase different charging leads and things to get their phones using. They, you know, they're away at university having a good time. They're not particularly thinking about electrical safety, so we want to protect those areas. And again, with care homes, in years gone by, there's been some tragedies in care homes with electrical fires, and therefore it made the list. So we ended up with a situation where we didn't have a mandating across all circuits and all areas, but areas that were sort of justified as needing this higher level protection. And because it was a recommendation in the 18th edition for all areas, it remains a recommendation for socket outlet circuits in other premises. And you might be working in a thatched cottage, in house, and decide that do you know what, this would be good protection on the upstairs lighting circuits that are in the loft under the thatch if there's evidence of vermin activity or whatever. So these devices, they provide additional fire protection, and check them out. So I've pulled in EV charging now, and we're sort of getting towards the end of the presentation, and then we can go to questions, but there's a couple more topics to discuss, and EV charging is one. It's quite a complicated topic. We have a lot of issues with earthing systems and different devices, but with regards to consumer units, let's look at the requirements for RCDs. So RCDs need to be able to disconnect all live conductors. So we know that, brilliant. And we've got the devices to do that. But in Amendment 2, we have this word here added, okay, individually. So when we protect a electric vehicle charge point, we need to do it individually. We can't use a RCCB that's feeding other final circuits. It needs to be individual protection. Let me try and explain some of the reasons behind that. So if you look at the text at the bottom here, except where the EV charging equipment deals with it, RCD shall be a type B or an A or an F in conjunction with a residual direct current detecting device, an RDCDD. Now, a lot of these charge points have an RDCDD built into them, and they're set to 6 milliamps because they know that the type A device can deal with 6 amps. It can carry on working, no problem. Okay. If the DC current is to rise above 6, then the RDCDD in this charge point disconnects the car, the charging stops, everything settles down with the batteries and what have you. And only when the presence of DC falls can it then recommence charging. So that RDCDD is looking after that type A device. Okay, it's making sure that it's not impaired, it's not blinded, it's not masked, whatever wording you want to use. So if we was to use a shared RCCB type A that can only deal with 6 milliamps, you may have almost 6 milliamps coming back from the EV charger. So it's at the point of saturation. Now the other circuits that are shared on it, they've only got to put a tiny presence of DC back through that device and it will be blinded. Okay, so that's why for EV charging, we want to individually protect them, because we're expecting a presence of DC, and we want to make sure that we can have protective devices that are not blinded and they're going to sit there and do what they should do and keep the installation safe. So last topic before we go to questions is regarding rated diversity factor. So this is not a new term. If you was to read the instructions in consumer units, I'm sure you all do, they're a riveting read, but if you was to look in there, there's lots of information that you should really be aware of. And the rated diversity factor is the value of rated current assigned by the assembly manufacturer, okay, to the outgoing circuits of the assembly that can be continuously and simultaneously loaded, taking into account the mutual thermal influences. Okay, so you need to consider it where circuits are continuously and simultaneously loaded, okay, because they can heat each other up, which can lead to thermal damage. It can also lead to unwanted operation. So if you remember back where we had the solar PV that was constantly loaded, to stop it being simultaneously loaded with another load, I put a blank in there, didn't I, on the demonstration? And that's what we got to look at, is how we connect our units. In the old days, they used to teach people at college, start by the main switch, put all your heavy circuits on and then down to the lights. It's totally the wrong thing to be doing. loads in years gone by, we used to have a lot of loads that were cyclic, and we still do have them, you know, cookers and things that go on and they go off. And if the off time is longer than the on time, then generally we don't need to concern about these. But when we've got the on time greater than the off time, such as with EV charging, it can be on and it can be on for many hours, we do need to consider rated diversity factor. So this is a table that's come from one of our training courses, which are available at hager.learn.com. And you'll see that these numbers, which are taken from the product standard, these are the rated diversity factors. So just like you guys apply diversity when you're designing cable sizes, because if we didn't apply diversity, we would have to have massive cables and massive switch gear to be able to deal with you know, the connected loads. We need to use diversity. So we do it the same as manufacturers. And if you look at the bottom row there, for a consumer unit that has 10 outgoing used ways, the diversity factor is 0.5. So what that's actually saying is the device can only safely work at half of its rated current. If it's going to be constantly and simultaneously loaded. So it's quite a concern that you pay attention to this. You move devices that are constantly loaded to the end if you can. You leave a gap, and if there is not that ability, you can consider what you're putting it next to. So put it next to a circuit that's not constantly loaded, something like a ring circuit that sits there, maybe the kettle goes on and the kettle goes off, but it's not loaded for a long time. It's not, in which case it's now not providing that simultaneously loaded characteristic, and the device can deliver its full load. Okay, failing that, you're going to have to put larger circuit breakers in, which will require larger cables. So it is a concern, and you do need to consider it. Now, the other thing you can do is talk to manufacturers. So Hager has done a number of testing, and they will be able to say you can use this size device in this configuration, just like the example I showed you with the solar PV. We have the test data to be able to tell you exactly how to test it. And again, some of this is on our website in the Hager Academy. Just check it out, and you'll get that greater knowledge of this topic. But I hope I've explained it. It's quite a difficult one to explain, and I hope you've understood it. We do have some other information that's available. I'll just put this up on the screen whilst I'm talking. If you have a look at this QR code, or you go to the link, we do have a 18th edition Amendment 2 bite-sized guide. We also have a number of resources on our online training academy, which I've spoken about. If you go to any of the major trade shows, Hager are always there, and we've always got technical representatives on the stand. It's usually myself or Paul Collins, able to deal with these topics and give you technical support. And lastly, we've sort of come to the end of the webinar schedule we've been doing with Rexel. We've done about 5 or 6 once a month, but this is the last one that's coming on the 15th of December, where we're going to give an overview of the 18th edition and the changes that come about in Amendment 2. And like I said previously, if you'd like to check out some more of these Hager Rexel webinars, please look at the YouTube channel. I'm sure the guys at Rexel there can direct you to the correct place to be looking to catch up on anything you've missed. So I think we're there now, Jamie. We can go to questions if you've got any.
Yes, thanks, Paul. Thanks for a really insightful presentation. In terms of questions, we've only got a few. If anyone does have any questions, please pop them into the questions box now, and we'll try and answer as many as we can. First one for you, Paul, is from Tony. Do Type AC RCDs need replacement for minor works jobs, for example, changing a broken socket?
Okay, I mean, that's a really good question. So when we talk about broken accessories, we usually, and this is not just a Hager thing, this is like an industry thing. We would usually allow a like-for-like replacement without doing any upgrades to the existing installation. Because the issue is, if you said, oh, you can't change that broken socket unless you upgrade the consumer unit, the client may decide not to do the maintenance, and therefore we may leave a potentially dangerous situation. You know, it may be a cracked socket this week, somebody plugs in and out of it, and now it opens up, and we've gone from a C2 to a C1 kind of code from a EICR classification point of view. So what we would say is you're absolutely fine to replace that broken socket, and you could recommend the on your, if you use a MonoX form, you could recommend the upgrade to a Type A device. All clients are different, as you know. Some clients will trust and value your opinion, in which case you might want to say, look, I'm going to change your socket, and we should be updating your device now. These old ones are not as good as protection as you could have, and certainly for a Hager consumer unit, it is a straight for straight swap. You can take the Type AC out and put the Type A in there, relatively pain free, and the client's got you know, a higher level of protection because their RCD is able to deal with that presence of DC. But I hope that's cleared it up, and I hope I've interpreted the question correctly. But in summary, yeah, if you've got maintenance to do, you know, crack on, get it done. It's important that we remove any potentially dangerous situations in clients' properties or homes.
Cheers. Thanks, Paul. Another question from Andy. Do EV charge points need RDC DD protection if Type B RCD is used?
No. So the regulation is you can use a Type A or an F if they're backed up with this RDCDD, the residual direct current detecting devices. Too many Ds in this now, AFDDs, RCDs, RDCDDs. But yeah, essentially, you use an RDCDD with a Type A or an F, but if you've got a Type B device, it's not worried by the DC, and it will deal with that job, no problem. Unfortunately, Type B devices are more expensive, and they usually take up more ways in the consumer unit. So not ideal, which is why we've ended up with this Type A used with the RDCDD. Seems to be the adopted approach to many EV manufacturers out there.
Cheers. And last but not least, from Stephen, can you still use plastic consumer units outdoors?
Yeah, it's we're starting to see that actually. We're seeing that, especially with EV charging, we're seeing different approaches to people getting that power to the charger, and there's nothing wrong with a plastic consumer unit used outside. So the regulation off the top of my head is 421.1.201. That regulation deals with installations within a dwelling. Okay, so if you're within the dwelling, you need to protect against that outbreak of fire or whatever by having a non-combustible consumer unit, or a consumer unit that's enclosed with a non-combustible material. If you take that second option, you've got to make sure that you don't breach any accessibility requirements. Okay, so you can't just box it off. The customer still needs to be able to access their devices should they need to reset anything, or should they need to test any RCDs or anything like that. So the question about going outside, it doesn't really fall under the intent of 421.1.201, although there's nothing to preclude the use of metal outside, but of course it would need to be suitably rated for the external influences that are present outside. So that's why most people would generally use a plastic consumer unit with a suitable IP rating.
Brilliant. Thanks for that, Paul. No more questions, but obviously, as Paul mentioned, there's a lot more material available from both Hager and at rexel.co.uk. Feel free to visit, and there's a whole catalogue of useful information that you can make use of. I'd just like to say thanks everyone for joining. Thanks again, Paul, for such a brilliant presentation. As I mentioned at the start, CPD certificates will be sent directly from CPD. They can take 4 or 5 weeks. Obviously, please feel free to reach out with any inquiries over to marketing@rexel.co.uk. Look forward to seeing you in any future webinars, and have a great weekend, everyone.
Thank you.
Thanks.